All right, today we want to talk about the factor theorem, and this is a spin-off of our remainder theorem, meaning that it's based on the remainder theorem. Now, with the remainder theorem, what we saw is that if we had a particular polynomial and we try to divide it by a linear function, right? We saw that we could calculate what the remainder is by taking the dividend divided by the divisor, and we would be able to determine whether or what the remainder would be. So that's better done with an example, right? We could come back and look at the formula or look at the reasoning behind it. But let's look at an example first. Let's say, for example, we have this function here, which is 8x cubed minus 22x squared minus 7x plus 3. Now, they want us to determine which one of these, right, these linear divisors, because they're in the x to the first power or to the power of 1, which one of these are factors of this polynomial, 8x cubed minus 22x squared minus 7x plus 3. Now, what we learned from our remainder theorem is if we let p of x be equal to this polynomial here, 8x cubed minus 22x squared minus 7x plus 3, and we take the linear, let's take the linear factor, or the linear divisor, I should say divisor, x plus 3. Let's put it equal to 0. So x is equal to negative 3. If we, or when we divide px by x plus 3, we could determine the remainder from finding the value of p of negative 3. This negative 3 is coming from right here, right? So what we did is we found a value of x when if we replace x here with a negative 3. Yeah, sure, go ahead.
Supposed to be sharing your screen.
Yes, 1 second. We're not seeing the screen. I'm not seeing the screen. Let's see. Seen it now? All right, lovely. Right. So we're talking about this is the polynomial I was talking about. 8x cubed minus 22x squared minus 7x plus 3. We want to divide it by x plus 3. Now, what we could do is we could, any function, if we let this polynomial be equal to px, we could substitute x to be negative 3 here into this in order to find out what the remainder would be. So if we drop a negative 3 inside of here, right, what this would work out to be is, so actually seen it right here. Negative 216 minus 198 plus 21 plus 3. And this will work out to be negative 390. So this is the remainder when we divide this function here, or this polynomial, by x plus 3. Now, let's think about something. If a number is a factor of a number, let's say, for example, the number 3 is a factor of 9. If I take 9 and I divide it by 3, I will get 3 with a remainder of 0. Again, if I take 16 and I divide it by 4, 4 will give us a remainder of, this will give us 4 with a remainder of 0. If I take 32 and I divide it by 2, 2 will go into the 16 times the remainder with 0. So factors have no remainders, or the remainder would always be equal to 0. Remainder would always be equal to 0 when something is a factor, or when a number is a factor of another, right? The remainder would always be equal to 0. So using our remainder theorem, or the way in which you would have calculated the remainder of a polynomial, we could identify factors of a polynomial. Now, in this particular example, they said determine which of the following linear divisors, x plus 3 or 4x minus 1, is a factor of this polynomial 8x cubed minus 22x squared minus 7x plus 3. Right? Now, since we substituted x to be negative 3 into the polynomial, and we got a result of, the answer here was negative 390, it means that x plus 3 is not a factor, right? Because we have y, because we have a remainder. This here is a remainder. Factors don't give a remainder. Now, if we look at the other linear divisor, which is 4x minus 1, and remember, if we have 4x minus 1, make x, put it equal to 0, set it equal to 0, we move the 1 across, we move the 4 across, x will be a quarter. If we find p of a quarter, right, what we'll work out to get here, as you can see, will be 1/8 minus 11, 8 minus 7, 8 plus 3, right? Let's test that. Instead of writing 7 over 4, let's write this as 14 over 8. And instead of writing 3, let's write that as 24 over 8. So it's easy for us to work all of these out. So 1 and 24 will give us 25 over 8. And 11 and 14 will give us 25 over 8. So 25 over 8 minus 25 over 8 will give us 0. Now, since there is no remainder, the remainder here is equal to 0. That suggests that 4x minus 1 is indeed a factor. Now that we know that it's a factor, we could divide this polynomial by 4x minus 1 to find other factors, right, of the polynomial. So we will first identify whether a linear divisor is a factor. After we identify which one is a factor, we'll then take that same linear divisor now and divide the rest of the polynomial by this linear divisor. And we did division of polynomials before, so we're going to do here 4x into 8x cubed. That's going to give us 2x squared. Multiply, we get 8x cubed minus 2x squared. We subtract the 8x cubed minus 8x cubed will give us none. This minus by this minus here give us a plus. So we end up with negative 20x squared. 4x into that will give us the minus 5x here. Minus 5x by the 4x will give us back the negative 20. Minus 5x by minus 1 will give us plus 5. And we'll continue like that. And look, no remainder. So it means that this is a factor and the 4x minus 1 is a factor. Now, we could go one step further because we could check our quadratic. The quadratic 2x squared minus 5x minus 3 could be further factorized. 2 by negative 3 will give us negative 6. And we could use a minus 6 and a plus 1. Right? That's right here. And if you further factorize this, you get x minus 3, 2x plus 1. So it means that all of the factors of this polynomial, 8x cubed minus 22x squared minus 7x plus 3, would be equal to that 4x minus 1 plus, or multiplied by, sorry, not plus, into x minus 3 into 2x plus 1. These two we get in from the factorizing of our quadratic factor, right? So we had a linear factor. This here is the linear factor, which we test to make sure it was a linear factor. We got a remainder 0, so we know it's a linear factor. To identify our quadratic factor, we then divided this polynomial by 4x minus 1. Got the quadratic factor, and then factorized that in order to get the product, right, of the other two factors. So now we know that these are all the factors of our polynomial 8x cubed minus 22x squared minus 7x plus 3, right? So to write it in its fully factored form, this is what we'll be looking at. Everybody okay with that? Now, we could use or we could evaluate unknown coefficients using the factor theorem, similar to what we did in the remainder theorem as well, right? So for example, if they say here that 3x to the 4 plus px cubed minus qx squared plus 4 is divisible by x squared plus x minus 2, evaluate the values of the constants p and q. If it is divisible, if we say something is divisible, if I tell you that 64 is divisible by 8, it means 8 could go into 64 8 times, and more importantly, with no remainder. That's what the word divisible means, right? It could go into that other number, or a divisor could go into a dividend, give us a quotient with no remainder, right? So what we could do first is we could first list our polynomial as a function. Px is equal to 3x to the power 4 plus px cubed minus qx squared plus 4. And then we could factorize this would be considered a quadratic factor, right? Because they said the polynomial, I'll just call it p of x, is divisible by this quadratic factor. So if we factorize x squared plus 2 minus 2x, we'll get x plus 2 into x minus 1. It means that these two are factors of them. So if we substitute the values, so that means x plus 2, x minus 1. And if we transpose here, so when x is negative 2 and when x is positive 1, if we substitute that into our p of x, p of negative 2 should be equal to 0, and p of 1 should also be equal to 0. Now, what we could do is we could sub these values in, as they did here. They worked out what p of negative 2 was, right? And that gave 52 minus 8p minus 4q, right? All of this should be equal to 0 because p minus 2 is a factor. Now we could rewrite this, right, as two simultaneous equations, right? When we substitute 1 into this, we'll get 3 plus p minus q plus 4, right? All of that is equal to 0. We could transpose and write this as another right? So we could rewrite this as p is equal to q minus 7, right? Or we could say q is equal to p plus 7, any one of the two. And what we could do is use our substitution method for solving simultaneous equations. And we could actually work out our values of p and q respectively. Yeah? So let's try a question. We'll try one of each. How about that? So let me grab a question. We do 2 of each. And then I'll do 2, and then you will do 2. Right. Use the factor theorem to determine whether g of x is a factor of p of x. So let's look at A first. So we have p of x is equal to x cubed minus 7x squared plus 3x plus 15, right? And we have g of x is equal to x minus 2. If g of x is a factor, then we take x minus 2, set that equal to 0, x is equal to 2. Then p of 2 should be equal to 0. Right? So we're going to test that. So p of 2. So we get 2 cubed minus 7 by 2 squared plus 3 by 2 plus 15. 2 cubed going to give us 8. 7 by 4 will give us 28. 3 by 2 will give us 6. And this is our 15. 6 and 8 is 14. 14 and 15 is 29. 29 minus 8 is equal to 1. So x minus 2 is not a factor. All right? Let's try for when we have p of x is equal to 2x cubed plus 6x squared plus x plus 3. And we have g of x is equal to x plus 3. So x plus 3 is equal to 0. X is equal to -3. So if we sub here, 2 into minus 3 cubed plus 6 minus 3 squared plus -3 plus 3. We will get here 2 by -27 plus 6 by 9 plus, just record that one time, plus by minus is our -3. Plus 3. -54 plus 54 minus 3 plus 3. This is equal to 0. So that will mean that x minus 2 is a factor. Now, since x minus 2 is a factor, that can't possibly be the only factor, right? You have to check. So, since x minus 2 is a factor, let us take x minus 2. And we're going to divide this polynomial by x minus 2 to find what the other factors are. We know it's going to have other factor because this is to the power of x to the power of 3. So it must have a quadratic factor other than this linear factor. X into 2x cubed is going to give us plus 2x squared. Plus 2x squared by x will give us the 2x cubed. Plus 2x squared by -2 will give me minus 4x squared. I'll get plus 10x squared here. Minus any minus will give me a plus. These two will cancel out. 6 and 4 will give me 10. X into plus 10x squared will give me plus 10x. Plus 10x by x will give me 10x squared. By minus 2 will give me -20x. Bring down this other x here. Subtract, we're going to get negative by negative is a positive, so I'm going to end up with 21x. X into this will give me plus 21. 21 by x is going to give me 21x. 21 by -2 is going to give me -42. And get 0. It's going to give us positive 45. So because we have a remainder, then x minus 2. Oh no. Where did I get x minus 2 from? It's supposed to be using x minus 3. I had 3 here. How I change that to 2, eh? And it's not even x minus 3. It's x plus 3 is a factor. You gotta be careful. All that working. And you copy the wrong thing. Pressure in exam. Time gone. Panicking now. It's alright to fix it. 2x cubed plus 6x squared plus x. Right? Now, if it's a factor, then I should be getting a remainder. And if I divide this, 2 2x cubed by this, I should get the other quadratic factor. All right, so remember, if we use the -3 here, then the factor is going to be the x plus 3 and not x minus 3, right? So we're doing this over again. We're going to get 2x squared. I'll get back the 2x cubed here. I'll get the 6x squared here. Right? Subtract, we get 0, 0. I'll bring down this other plus here. X into that will give more. Plus 1. 1 by x will give more x. And 1 by 3 will give more 3. Now notice how because we didn't get a square value here, I had to miss this term here. I'm bringing this down here, right? But I don't have anything like that in my quotient. I'm going straight from x squared to plus 1. Follow? Because x into x is going to give me plus 1. It's not going to give me x, so there's nothing coming here. I can't write the 1 over the x. The 1 have to go in line with the 3. Right? Pay particular attention to that. When you multiply it back out to it will work out because I'll multiply 1 by x to get x, 1 by 3 to get 3. And when I subtract it, I'll get 0. So we know that this checks out. X plus 3 is a factor. And the other factor is 2x squared plus 1. Right? So we could safely say that 2x cubed plus 6x squared plus x plus 3. If we factorize it, it will work out to be x plus 3 into 2x squared plus 1. You okay with that?